Good afternoon, all, and welcome for today's second session on quality improvement in engineering colleges. Now I invite Dr. Teres Yamuna Mahesh, Associate Professor from Electronics and Communication Engineering Department, to introduce and welcome the resource person.
Thank you, Ranjana Miss. And welcome, sir, for the second session to Amal Jyoti College of Engineering. For those of you who have joined newly, I will introduce sir again. He was introduced once in the last STTP. And Sri Amitabh Saxena is founder of Annexus Group of consulting companies, which has offices in 5 countries and clients in more than 25 countries. He is a Lean Six Sigma project management, strategic management, and artificial intelligence trainer with 30 years of experience in IT, manufacturing, financial services, ITES, healthcare, and logistics domains. He has implemented Lean and Six Sigma process excellence initiatives in more than 50 organizations in India, Europe, GCC, and Middle East, and trained more than 25,000 professionals. By education, he is a chemical engineer and MBA Finance from Jamnalal Bajaj Institute of Management Studies, Mumbai. Sri Amitabh has authored an Amazon best-selling book, The Annexus Story, which describes his journey as an entrepreneur after working in corporates for 20 years as a quality professional. Sri Amitabh has received many international awards for his contribution to process excellence, entrepreneurship, and innovation. He has authored 2 books and writes weekly column in Indian newspapers. Business magazines and TV shows have featured him for his exemplary work in process excellence, leadership, and entrepreneurship. We welcome you, sir, to this session.
Thank you, Dr. Teres Yamuna. And it's a pleasure to be here once again and always sharing the knowledge with all the people and the professors. And being myself an engineer, I was, I remembered my college days. I'm also very active in my alumni association, Engineering College Alumni Association. So when I was given an opportunity to talk about the using quality tools in improving the performance of the students in the engineering college, and also in general improving the engineering colleges. I'm very excited, and thanks a lot for inviting me. Okay, so some of you have already attended the session which I had conducted earlier. So first 20 minutes or half an hour, maybe I will talk a little bit on similar lines because some of you have not attended it. So I will try to tell you some same concepts. Now my focus would be on the Lean Six Sigma, and also one more thing. I'll be teaching you some tools and techniques. You are you'll be qualifying to get a get a certificate of yellow belt after this session. So just let us know in case if you let me know if you are interested in getting a certificate as a certified yellow belt. So we can the electronic certificate can be given to all of you. And of course, if you want hard copy maybe little, means some administration cost will be there for that. But if you want e-certificate, a yellow belt certificate, Lean Six Sigma certified yellow belt certificate, you can send me the details, your email ID, and I think some details might be needed, and then you will be qualifying for the yellow belt certificate. Okay, so now let us very quickly, just to give you an idea, we'll be talking about what is Lean Six Sigma. Now, I'll share some of the case studies. Now, because in engineering colleges, ultimately the engineers are going to become managers, and engineers are going to work in organizations, and these organizations are always talking about quality improvements and reducing the costs. So Lean Six Sigma is very much applicable to all your all the industries, all the engineering industries. So I'll talk about DMAC, define, measure, analyze, improve, and control. Then I will take some examples. Maybe I'll take an oil industry example uh, from Middle East, and this will give you an idea what Lean Six Sigma is. And then after that, I will apply. Means I will take an example of how we can apply this to engineering colleges. So there, and after that, I will be open to some discussions. The whole idea of this session would be to enable you to learn some tools. Using those tools, you can apply the statistical tools and techniques to improve the uh, overall anything in an engineering college. If you have got some specific area, something specific, very specific, which you'd like to talk about, you can tell me right away. I can even take that example, or I have a generic example like I think last time I don't remember. I showed an example of increasing the scores of engineering students. Did I show that example last time? If you remember, I can maybe revise that example also, or otherwise I can talk about that example only. Anyone remembers which example I had taken last time when I had talked about quality? I had focused more on the last time qualitative improvements and improving the quality in the education. But right now, maybe I will focus more as a more on learning the tools and techniques to solve the problems and applications. Okay, so here, just to give you an idea about the organization, we have done training programs worldwide. More than 150,000 people have been trained by us. And just give me a second. And these are some of the photographs of as a proof that I have done the trainings worldwide. Last time also I showed. This is a Chinese hospital. This is again manufacturing companies in one is pharmaceutical company, one is manufacturing company in Europe, and this is US Pepsi manufacturing plant. Won some awards, etc. Appeared on TV shows as spoken in American Society of Quality World Conferences, and of course done a lot of work in refineries and railways. So all engineering industries we have covered. Now, can you tell me some of the similarities here? What do you see here? What are the similarities you see here? And some of the people who had attended the session last time, they can, I think, answer it much more easily. So, what are the similarities you see here? And I can also add one more thing, that one of the engineering colleges reduce their operating costs by 20%. So what do you think? What do you see here? Are there any similarities? Yeah, I think people are able to write in the chat box. You may have to open the chat box, I think. I think people are not able to write because I don't see any response.
But
Okay, no issues. So okay, so all of them have used Lean and Six Sigma and data analysis to achieve the breakthrough results. So I'm here to tell you, and of course, I'm here to make you a yellow belt so that you know some tools and techniques so that you can apply all these tools and techniques to your engineering college also. So lots of organizations worldwide have used this. Lot of 80% of the top 100 Fortune 100 companies have used it. 70% of the top Fortune 500 companies have used Lean Six Sigma, and many of them are our clients. So Lean and Six Sigma can do all these things for any organization, including an engineering college. So first we have to think from systems perspective, not from individuals perspective. And how do you achieve this? How do you achieve all the things which are listed here? So you can see that it reduces the cost, it reduces the defects, it reduces the waste, reduces the rework, it reduces the cycle times, like time taken to complete the admission process in your college. Administrative costs can be reduced drastically so that the college can divert the funds to something beneficial to the students or the customers or to the professors. Defects, errors can be reduced drastically. Waste. Now, we are not talking about the general waste which goes into the dustbin. We are talking about the process waste. So we will learn about what are the different types of process wastes. Okay. We reduce the rework. So a lot of examples of rework in our colleges. We can reduce the rework drastically. We can increase the quality, increase the efficiency and productivity of our professors, of our faculty, and also our students. And overall, the customer satisfaction. Who are our customers for colleges? The engineering colleges, the customers are, of course, the students. Customers are the parents of the students. And customers are the government or the regulatory authorities. They are all our customers. Measure from customers' perspective, how are we performing? And once we measure from customers' perspective, how are we performing? Our mindset totally changes. And for that, of course, we have to think in terms of process orientation, not people orientation only. So processes are the key areas or the places where efficiency is nurtured. Okay. Let me borrow one slide from my my regular green belt training just give me a second. Because what happens most of the times, we think in terms of individuals, we think in terms of departments. I am from this department, I am from this building, I am from this floor. Now, what happens is when you are looking at only focusing on a department's perspective, the focus is narrow, and that's definitely not going to improve the efficiency of your organization. So if I am looking at increasing the efficiency of the organization, yes, this is the one I want. So the real organization are not departments. They are not the functions. The real departments, the functions are the residence and building places for competencies, of course. Mechanical department, electrical department. They are, of course, it should be uh, managed by an able professor, able administrator, able people. And that is very much required. And we are not contesting that. But when we are looking at overall improvement of the efficiency as an engineering college, the departments are focusing on a particular uh, just one department or only people is not going to deliver the result. Why? Because customers are not dealing with people, not dealing with departments, they are dealing with processes. Customers make an impression about your college. And I told you who are your customers. Customers make an impression about your college based on your process. You may be very good in your knowledge. You may be very good in giving a lecture. You may be very good in teaching the students. But the output, whatever is the output, it can be the number of percentage of placements done, or the average salary obtained by the students in the college, or it can be overall knowledge levels or knowledge gained by the students in the college. All is going to be a result of a process. And the processes cut across departments. Processes cut across like administration, marketing, sales, public services, administration, plus of course the faculties and teaching. So it cuts across the processes. So we have to think from process perspective. And then there is a lot of waste in the process. So let me talk about the different wastes which we observe in the process. There are different types of wastes. We call it as 7 or 8 wastes in our processes, which are present, very much present in our college. Everywhere it is present, not only in the college, it is present in all organizations. So let me talk about that. And these 8 wastes, which we call it as hidden factory, or a lot of the times, how will I reveal those wastes? Well, I have to map the processes. Most of the time, when the people who are working in an organization, they are always thinking from their job's perspective. This is my job. I have to come at 9 a.m. I have to finish my job by 5 p.m. And these are the 3-4 activities which I'm going to do. But there is no end-to-end understanding of the process. So the first thing which we tell any organization to do is make a systems map. Systems map means supplier input, process, output, and customer. SIPOC. Okay. So if I were to do a SIPOC for your, say, let's say an engineering college, let me do a SIPOC for an engineering college. SIPOC is supplier input, process, output, and customer. Supplier input, process, output, and customer. Who's the customer here? Is it possible for you to write in the chat box if? Yeah. Who's the customer here? You can write in case if you want, you can please write. In your college, who's the customer? Student is the customer, right? The parents of the students are the customers. The university to which you are affiliated, in case you are affiliated, otherwise, if you're so your of course the management is also the customer. And what is the output? Output of our whole process in an engineering college. What is the output? Output is the educated or qualified student, isn't it? And what are the processes, the basic process steps? So right now we are trying to understand the systems in which we are operating. What is the systems map? What is the what happens like as a process of education? So you have you receive a student, like of course, so I'll just say receiving a student, receive a student, uh, uh, say, I would say train the student or educate the student, then evaluate the student, of course, say give suggestions or whatever, counsel the student, I would say, counsel the student, and finally certify or basically award a degree certificate. So again, if I can say, certify the student. So these are the basic steps. And what are the input factors? What are the inputs to this process? Who are the inputs? Like faculty are the inputs. Course material is the input. Books. Nowadays, even online platforms are the inputs. What can be the inputs? I'm talking about supplier input, process, output, and customers, SIPOC. Okay. So the first thing is, whenever I am trying to improve something, I have to make a systems map. The systems map is known as SIPOC. Supplier input, process, output, and customer. SIPOC. Okay. Now, once I know that this is the system I operate, I can think of improvements. Okay. So, of course, here you can write the suppliers of who's supplying the faculty, the management. A course material is being supplied by different sources. Books are supplied by, let's say, library or bookstores, and online platform is supplied by the some, say, Zoom or whatever. Now, why am I interested in learning this? Can anyone guess? why this is the starting point? If I want to improve the quality, or if I want to do generic improvements in my engineering college, why I have to do the systems math? Any guesses? If you can interact, right, that will be really good. Then I can even see, because the output, actually the customer is interested in the output, and the output depends on the process and inputs. So I should know what goes inside the process. So I should know what is going inside the process, right? And what is going inside the inputs. Because inputs and processes are responsible for giving me the outputs. And because I want to improve the output, like the education level of the student, I want to increase the scores of the students, I want to increase the general, see, because all these things will lead to the better brand image of the college, isn't it? So I want to increase each and everything so that the whole education process is fruitful. Most of the time we just focus on the output. No, the output actually depends on inputs and processes. So our focus should be equally be on the inputs and processes. And we call these as X factors. We call these as X factors. And we call this as Y factor. The Y is the output and X is the input. X factors are the inputs. Now, if I want to improve something in Y, you need to improve in X. Now, not all X factors are going to affect your Y. Some of them are going to affect the Y. So there is a Pareto principle, 80-20 principle. I hope many of you might be knowing it. 80-20 principle is 80% of your problems are in 20% of your inputs. So 80% of the time, I'm not able to educate the student up to a certain capability is due to only 20% of the causes. So you've listed down so many things, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 2 are responsible for the quality of the educated student. Only 2 are responsible. So out of 10, only 2, 80-20 rule. So which are those 2? All these things can be easily achieved and all these things can be easily known. How? By using data collection. So I have to collect the data. Once I collect the data, then only I'll know which of the X factors is most affecting my Y. And this Lean and Six Sigma, generally, which we followed define, measure, analyze, improve, and control, is about first mapping the process, identifying the areas which need improvements, and after that, collecting the data on the Y and X factors and trying to correlate those data. And once you correlate those data, then you can find out the root causes where we are lacking. And after we identify the root causes, we can attack the root causes. So this is the whole initiative. This is the whole essence of Lean and Six Sigma. Up to here, any questions? Any questions on the SIPOC? Anything you would like to ask?
Sir, right now we don't have any questions.
Okay, fine. Now, the next step, I have to identify one area of improvement. Any one area. Let's say I identify, I would like to increase the scores of my students. Okay, in my college, on an average, they score 50 marks, 60 marks, whatever, on an average. With a, of course, when I collect the data, it will be normally distributed. Last time I had talked about normal distribution. If you want, I'll briefly talk about normal distribution one more time. So anything in your college, it follows normal distribution. All the things in your college, it follows normal distribution. Just give me a second. I hope some of you have heard of normal distribution. Yep. Normal distribution looks like a bell-shaped curve. One mathematician called Gauss, Carl Friedrich Gauss, he found that most of the processes, most of the repetitive processes in the universe, they follow normal distribution. So most of the repetitive processes in the universe, they follow normal distribution. Okay. So last time I talked about normal distribution, if you remember. Yeah. So when we are talking about the normal distribution, see, normal distribution means what? Like take an example of, let's say, age of the people who are attending this program. Not everyone is of same age. Maybe the average age of the people who are attending the program is, let's say, I'm just taking an example. I can't see you. If you can switch on your videos, I can see you for some time, and then I can make my guesses. But like, if I can just guess, maybe the age of the people who are attending this program is 35. Yeah, approximately 35. And not everyone is 35. Some are 40, some are 30, some are 45, some are maybe 25. So, it will be normally distributed. So normal distribution looks like this. And yeah. So age of the individuals. Oh, okay, I'm not sharing my screen. Just give me a second. So normal distribution looks like this. So if I take engineering college scores of engineering college students, it is, let's say, actually I had collected some data. I can use that data also. And those who want to use this Minitab software, which I'm showing you, if you want to use, you can easily download it from Minitab website. It is www.minitab.com. So if you want, you can always use it, and it is available on, this software is, the demo version of the software is available on minitab.com, www.minitab.com. So Mr. Gauss, he found that any repetitive process, it follows normal distribution. So if I collect 30 samples, if I just collect 30 samples of any process, like 30 students score, if I collect, I can find it has an average and it has a standard deviation. And he also found that the curve never touches the x-axis. It goes on and on, goes to plus infinity and goes to minus infinity here. And it appears to touch the x-axis at plus 3 sigma and minus 3 times standard deviation. So I have got 1 sigma, 2 sigma, and plus 3 sigma. And here it is minus 1 sigma, minus 2 sigma, and minus 3 sigma. So if I collect the data, say sample of 15, 20 students, and I get their scores. Based on that score, I can predict the performance of a college. Just 20, 30 scores. 20, 30 scores is good enough. So these are scores of the students. Let us say I take some student, one student scoring 60, 55, 63, 70, 58, 50, 45. No, these are the scores. I can easily find the scores of the students. What is the average? What is the standard deviation? So this is the average. Average is 61.7. It's the average scores of the students in this engineering college, or the group of engineering colleges. And standard deviation is 8. Yeah. So if I just, for the sake of my calculation, if I say 60 is the average and standard deviation is 10, let us say. So 60 is the standard deviation. 60 is the average and standard deviation is 10. So 60 plus 10 is 70, then 80 and 90. And here it is 50, 40, and 30. So 99% of the students are within 30 to 90. So this is how my process in the colleges performing. This is the students, this is how the process students are performing. Now, this -3 sigma, the -3 sigma is known as lower control limit, and upper, you see it, this is known as upper control limit. So lower control limit is -3 sigma, upper control limit is +3 sigma. If I plot this here, I can say that 30 to 90 is the, this is how my processes perform. This is how my process perform. Now, my aim is to improve the process. So first things, as I told you, the first thing you have to do a SIPOC. Understand the process. See, changing the mindset takes time. First, look ourselves from a systems perspective. That is one. Second is identify, go to the customer, ask the customer, what do you want? Customer is telling you, I need high scores of students. I need their salaries should be higher. I need your brand value of the college should be better. Now, this is what you are trying to achieve. So how would you achieve? First, did a SIPOC, then I go and identify one thing, any one thing which I would like to improve in the college. And then I convert this into a DMAC project. I identify an improvement project. The definition of a project is it has a starting point and it has an end point. It doesn't exist after some time. The project doesn't exist after some time. So it's a one-time activity. So you take up an improvement project. Okay. Once you have taken an improvement project, now you collect the data. So if I want to, let's say my objective is to increase the scores of the students, then I collect the data. I collect some samples and identify how I'm performing, how my process is performing, the way I saw here. Today, students are going up to 45 here, and here they are going up to 75, approximately. 45 to 75. This is what my process is looking at. Okay, here if based on my assumption, what I just saw, standard deviation is 10 and average is, let's say, 60. So this is how the process will be performing. So you have to get the assessment of the process based on the data. And you should have those data with us, with you. Whatever you want to, let time taken to completed admission, attendance of the students. All these things can be easily found out just by collecting a small sample size. And once you have done that, you make a control chart. This what I have done is I have made a control chart. So some students, most of the students are scoring 60. Some students are going up to 90 very rarely, but some are. And some are going up to 30 to 40 also. So all these things are there. All these things, all these possibilities are very much there. Now, most of the time, we spend the time worrying, oh, one student has scored 88. We feel very happy. Another student has scored 60. We say, okay. Another student has scored 35. We don't feel happy. And depending on how we are performing, going up, down, 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 up, down, you will feel happy or you will feel sad about the performance. But this is the wrong way of managing the process. Dr. Deming was a quality guru. He said, this is the wrong way of managing the process. Why? Because you are unnecessarily thinking about the common causes. Common causes. Common causes means you should not spend too much time on it. This is the natural variation of the process. We call it natural variation of the process. That means in my college, some students will be 35, some will be 60, some will be 65, some will be 80, and at times they can reach up to 90, not always. I'm just taking an example. The numbers may be different, right? Now, once I know the performance of the college, I would like to improve the performance. So just feeling happy about a student who is scoring 85 and 86 and ignoring that the students who are 55, 40, no, that's not right. You have to think from everyone's perspective. You have to think from as a system's perspective. So the system is monitoring, is operating within two limits. Consistently it's operating, for the last 6 months, 1 year, 2 year, 3 years, this is how we are operating. I need to change the system. The system will be changed only by following the statistical tools and techniques, following something like the MAC of Lean Six Sigma. And that is what I wanted to talk about. We call this as natural variation. Of course, some student might score 95 or maybe 0 marks, but they are treated as outliers. But this in general is our performance of the system. This is how we are performing. We call it common causes. Now, our objectives here, not to stay here, but I would like to improve, isn't it? I would like to improve. So, my main objective is to raise the levels of the students. So here, we call it as lower control limit and upper control limit. And just to give you an idea, this is known as lower control limit and this is known as upper control limit, LCL and UCL. So my aim would be to change the control limits of my engineering students. My engineering students should be scoring between, say, 60 to maybe 95. Now, this can be their salary also means, I'm just taking an example of a scores of students. It can be salary. Salary the engineering students are getting in their final years. I would like to improve that. So I'll collect the data for the last 2-3 years, what's happening. I'll create my control limits. And then after that, I will work. I'll do some work, I'll do a DMAC project, and then raise the levels, raise their salary levels. And this will happen again by following the tools and techniques which we are going to learn. Up to here, have you understood? The statistical concept, the control charts, the histogram, any questions? Okay, good. Now, once we know where we stand, we call it as measure. So we have done measure. The first we defined. Defined means I did a SIPOC. Then in the measure, I collected the data. Now in the analyze, I will analyze why whatever I'm trying to improve, why my performance is not up to the mark. So what are the root causes that you have to identify? What are the root causes of low scores of my engineering students? So here you can use a tool called Ishikawa diagram or cause and effect diagram. So let me show you the tool called Ishikawa diagram. Ishikawa diagram talks about, this is it looks like this. Yeah, I think you must have seen this. So this is the one way of identifying all the possible causes. So you put your problem here, like low scores of the students, and then what are the reasons for that, main reasons, then further branches and further sub branches. Okay, so you can identify that. Here also we did the same thing, and to identify those causes, Mr. Ishikawa from Japan, he had given this tool. He told that you can brainstorm on 6 M's: man, machine, material, method, measurement, and mother nature. So just to make it 6 M's: man, machine, material, method, measurement, and mother nature. Mother nature is also known as environment. So man, these are the causes: faculty, student, focus, health, interests. Material, books, laptops, desks, classrooms, study material. Machine, software, network, Wi-Fi. And then methods. So these are all the reasons of low scores of the students. I can make a cause and effect diagram. And I find that this is the low scores. These are the X factors. What are all the possible reasons? So of course, I collected the data, and after collecting the data only, I am making these cause and effect diagrams. Once I've got the cause and effect diagram, now not everything is affecting my Not everything in this these X factors are going to impact my scores of the students. So I have to do now Pareto. You can do a brainstorming session, you can do a voting technique, or if you have the data, real data. In this case, in this project, you may not have the real data, but just in case you have the real data, then you can even think of working on the real data. Collect the data about the X factors. What are the factors affecting your scores of the students? Collect some data and try to correlate the data using different techniques, which I'll be talking about in a short while. So I have done a cause and effect diagram. So I have done a histogram. I have done a cause and effect diagram. I can do a Pareto also. So these are the reasons for low score. So first student, oh, library was not the second, conferences, exams, tests, assignment, industry. These are the causes. Some of the causes will be occurring again and again. Some of the causes may be occurring very less frequently. So you have to arrange them in descending order, and you have to make a Pareto chart. Pareto means 80-20 rule. So going by the rule that if the data is continuous, I need a histogram. If the data is attribute, I can do a Pareto chart. So let me do a Pareto chart. So I just go and do a Pareto chart. Actually, if you want to learn Minitab, I have posted my videos on NXS YouTube channel. So and I think in one of the examples I had taken the college example only. So you can always have a look there about how I'm solving. So I did a Pareto. Pareto means it rearranges the causes which have highest frequency, which are occurring again and again. So it rearranges all the causes. Okay. So it rearranges all the causes which are occurring again and again, and in the descending order. So it is rearranging 15, 13, 8, 7, 7. And then percentage contribution is mentioned here, and cumulative percentage also. Cumulative means first two are this, first three are this, first four are this. So this is how we do a cause and effect diagram. Once I have done cause and effect and Pareto diagram both, then after that, I move ahead. So I've got now 4 causes of my problem based on the data. Now I will move ahead and try to validate each of the X factors with the Y. And that is what is the data-oriented process improvement. So whatever you are trying to improve in the college, whatever, try to think in these terms. SIPOC. You can write a project charter also, problem statement, goal statement. Then collect the data, make the histogram, get the chart, control charts, and then take an improvement action, make an improvement related effort, make an improvement plan for improvement. So all these things will lead to data-oriented process improvement. So we have learned the histogram, we have learned the normal distribution, we have learned the average and standard deviation, we have learned about cause and effect diagram, and we have learned about the Pareto analysis. Any question till now? Any questions?
No, sir.
Good. So after this, let me take you to the further analysis. But yeah, I think, is there any break scheduled in between?
No, sir.
Okay. Because last time I think you had given some break, if I remember correctly. If there is no break scheduled, then I can continue. Now we go to the further data collection. Further data collection means some of the X factors was industry interaction, study hours, the branch. Some people felt, oh, some branches scores are higher, some branches scores are lower. So it's due to the branch. So what can faculty do about it? The main reason is the branch. So everything needs to be validated. How to do that? Collect the data. The student number 1, industry interaction days. How much time she spent in industry interactions? 20 days. Does it impact her scores? Let us see. So industry interaction, study hours, she said, or we collected the data using maybe electronic gadgets nowadays, or maybe self-audit also. And these are the study hours. And then based on this, you identify whether study hours are impacting the scores or not. So how to identify that? For that, you can always use how will I analyze that? So depending on the type of data, so let me tell you, there are 2 types of data. Last time I talked about it. One is continuous data and another is attribute data. What is continuous data? Continuous data, like you can express in numbers. Industry interaction, 30 days, 30.1 days. It can have a decimal place also. And possibility of a decimal place is always there when we are talking about continuous data. But what about the attribute data? It is like a category, like branch. Branch is the attribute data. It's about category. Which branch? Management, engineering, mechanical. Is the branch impacting the scores? Is the industry interacting the scores? So if industry interaction is continuous data, and this is also continuous data, both are continuous data, then you can use a tool called scatter plot. Both are continuous data. You can use a tool called scatter plot. And when both are attribute data, I can use Pareto chart. And when one is continuous and one is attribute, I can use box plot. So let us see one by one how to do that. So when my score is, let's say, and this is the scores, and I want to see industry interaction is impacting or not. We feel that more industry interaction maybe increases the score. Let us see. Scores and interaction. I can do a scatter plot. Scatter plot. Scores and industry interaction. So Y variable is the scores, X variable is the industry interaction. If there's no pattern there, that means there is no interaction. Even if the person spends 10 days, scores are varying between 15 to 60. If I'm spending 40 days, still they are varying between 45 to around 75. So that means industry interaction is not the root cause. Don't think that more industry interaction will increase the scores. Maybe something else, it may, the industry interaction may be resulting in some gains, definitely. But in this case, if I'm trying to improve the scores of the students, the data is proving that it is not related. Or it may be related also. Here, let us say scores and study hours. Are they related? Again, let me do a graph scatter plot. With study hours. Appears to be related. That means the study hours, as I increase, scores increase. Now it has been proven that study hours are impacting. That means my emphasis should be how can I increase the study hours of the students. And then I'll devise a strategy, I'll devise a system so that they are able to increase the study hours as well. Any questions up to here? More the study hours, more the scores. I can even get a regression equation. Many of you are aware of regression equation. I can do a regression equation, y, straight line equation, y is equal to function of x, scores and the study hours. Let us see. This is the regression equation. So I can even predict the scores by just putting the study hours of the students. Now, of course, here, while I'm talking about this, data collection is important, collecting the right data is important. So you have to have some data collection mechanism, you have to have, and you don't have to collect too much of data, a little bit of data collection mechanism should be in place. Let me know in case you have any questions, or you are, means I hope I'm making some like sense, means I'm trying to correlate with the work which we are doing. Just just let me know. That is the fact. Okay. Now, one we have already seen this one, scatter plot. Now let us look at if one is attribute and one is continuous. What happens? If one variable is continuous and one is attribute. Scores versus, let's say, branch. Are they related? Should I focus on one particular branch or every branch is same? So in this case, I will go to the box plot. Scores. This is known as box plot. Now the box plot indicates that almost all the ranges for chemical engineering, management branch and mechanical engineering are almost, same. There is no specific difference, statistically significant difference between the three. That means I should be maybe working on the something else. I should not blame the branch. Don't think one branch is scoring high or low. Then let us do the same graph for the other one. Interest. Low, medium, and high. So you can see that when the interest is low, scores are low. When interest is high, scores are high. So I need to work on means and ways to increase or improve the interest rates of the interest of the students. This will be our recommendation. So this is how actually we do a data-oriented improvement project. And this is how we analyze. And of course, once we get to know about the root causes, I can work on those root causes using brainstorming and of course ask the experts, etc. Look at the journals and publications and find out some solutions from there, or even do a simple brainstorming and you will get a lot of solutions or ideas. Now there is another thing which is not related to this project, like of scores, increasing scores, but I'll just talk about it. How to increase in general overall efficiency of our colleges. So one of the recommendations is map the processes, the critical processes of the for your colleges, like admission process, evaluation process, teaching process, placement process. These are some of the processes I just talked about. So you map the processes and identify the value-added steps and non-value-added steps. So what are these value-added and non-value-added steps? These are also known as identification of waste in our colleges. The waste in the college, not the general waste which we throw in the dustbin, but the waste in the process waste. In the processes, there are different types of waste. How to identify the different types of wastes? Any step, any activity in the college which you are doing, and customers are not willing to pay for it, is waste. If it is not changing the product, physically changing the product, or at least working on the unit to bring it closer to the output, is a waste. Anything not done right the first time is a waste. So these are all the wastes. This is the criteria of waste. And what are the criteria? What are the different types of waste? Before I talk about it, let us see how to identify the value-added and non-value-added steps. So generally what you will do, you will first map the process, map all the processes. And once you map all the processes, you segregate what is value-added and what is non-value-added. So just to take an example, admission process, or let's say teaching process. Teaching process, if the student is waiting in the classroom, that is waiting waste. If students are asked to move from one classroom to another classroom, again, this is a waste. This process waste, movement. If there is a vacancy of faculty, then this is underutilized resource. This overburden also is a sometimes waste, considered waste. So only the process of educating the student, that is the value added activity. Remaining activities are non-value added activities. So you have to identify which are value added, which are non-value added. And then after that, you can analyze. There are some ways, some process work, some work which are not actually value added, but still we need to have them if they are regulatory in nature. If like law requires to execute those projects or those process steps, then we will not touch them. Anything which you are not doing right the first time, any rework, like one student who is repeating the session, repeating the year, actually is a waste. Why? But the first year, 1 year, we waste it, isn't it? So we have to ensure that any rework which is in the engineering colleges can be drastically cut down, and we should make everything right the first time. Re-evaluation, re-evaluation can be one of the examples here. And then we are also doing so much of rework in our processes, we call it as hidden factory. It's not visible to the outside world. Outside world doesn't know that there is a lot of activities taking place which lead to rework. Okay. And the 7 wastes, which is popular waste, we call it Tim Wood wastes: correction or defects, overproduction, overprocessing, transportation, inventory, motion, waiting. So try to identify those wastes in our colleges, and you should be able to improve some of the stuff and improve the efficiency of our administration processes and also in general education processes. Can we have some examples, like because I don't know, you're not able to we have got so many professors, isn't it? So many faculties here. So I would like I will expect them to give some have some interactions. Yeah. So let us make it as a two-way. So can you give some examples of wastes in our colleges related to waiting, related to approvals? Too much of approvals. Too much approval is also a waste. Yeah. Over processing, transportation, inventory, buying materials which are not required. That is a waste of inventory. Transportation, too much of movement of goods from one place to another place. Over processing means teaching more than required. So these are the 7 or 8 ways. Just wanted to talk about them. So this is some area which also we can think of when we want to make some improvements. Now, if you are interested in implementing this whole system in your college, generally how it works. So what I was showing you was just typical way of doing a project. Of course, after we have found the root causes, we also do some brainstorming session, and based on the brainstorming, we come out with some solutions and ideas, and then we implement them to improve the process in the college. But if you want to implement this seriously, now there are 5 colleges already we have implemented this Lean Six Sigma. And they are, in fact, they are in Middle East, and we have implemented Six Sigma and Lean Six Sigma, the same concept in those 5 colleges. 2 colleges we have done some work in India, Indira Institute of Management in Pune. There we have done some implementation work, not in a very end-to-end way, the way we have done it in other colleges in the GCC countries. So we have got for 3 Saudi Arabian colleges, 1 in Muscat and 1 in UAE, who have implemented Lean Six Sigma. this whole methodology. So how it is done. Now I'm talking about in general how it is done for all organization. And similarly, we can apply all these same concepts to our college as well. First thing is, for all departments, instead of business A, business B, you can say all department A, department B, department C, all branches. You identify top 3 areas which you would like to improve. So you ask the department head, what are the top 2 things you would like to improve in your college? Any top 2 things, top 2 or 3 things in your department, whatever you would like to improve. This becomes the input for our project. So once I identify which are the areas which I would like to improve, I convert these improvement opportunities into projects. Then the director of the college or the principal of the college, along with the senior management, they constitute a steering committee comprising of 3 to 4 people, senior people, and they agree to monitor the Lean Six Sigma initiative in the college. And then you tell faculties. Sometimes you can tell students also to participate, but students who may not be, they might not agree also, first of all, because they are already burdened. And if you ask them to do something else, naturally it will be diverting them. But some of the faculties, they become green belts. They know these tools and techniques. They undergo a formal training in Lean Six Sigma, and they are capable of improving any project in any industry, any process in any industry. So here, the people, mostly here in this case, the faculty members, or maybe some people from admin team, even IT team, HR team, if it exists. These people from the college, who are staff of the college, they become green. They are given the role of green belts. And then they take up improvement projects. And to understand this whole concept, usually we recommend that 2-hour training. Like right now, I'm doing a 2-hour training, but I'm not sure whether it's for same college or it's a group of colleges. But right now, the one what I'm conducting a training is about giving you a generic overview of Lean Six Sigma. So that's also known as champions training. The 2 to 3 hours training for the senior management or middle management about what is Six Sigma. Also known as yellow belt training sometimes. Champions means the senior management is attending. That is why we call it champions training. So here, the 5 colleges where we have followed this methodology. First, we created with the infrastructure, trained the people, trained the employees, trained the faculty members, trained the employees of that university. Then we asked them to do some small improvement projects. And then we transition. Transition means after they have completed the project, we said goodbye. So this is what you do. Some of the success factors, if you want to maintain this whole initiative in the college running, for a long time, because it should not happen that just someone got trained as a green belt and then maybe you did a project after that, people forget about it, or they're not even doing a project, maybe. So how will you ensure the success and maintain the momentum of this initiative if you have implemented? So try to use all people across if you have got 7, 8 branches, involve each of those branches so that they don't create silos. people. You should not work in silos. Right? Efficient project governance, project duration under control, efficient training programs, certifications and important attached to them. Six Sigma and best practices for like you can attend, you can organize seminars for from all around the country maybe who have implemented Six Sigma, and you can you can share the best practices. That can be one of the ways of sustaining the enthusiasm. And publicizing the success. So whenever any faculty completes a small improvement project, it is not necessarily he or she will be using all the tools and techniques which I showed it to you. This is just brief tool and technique which I just mentioned. But if some people have been successful in implementing Lean and Six Sigma in the college and they completed a good project, you should publicize that success. And once you publicize the success, it will motivate others also. Yeah. So this part I had last time covered, but I'll just show you very briefly. There are two types of data. Or I just to ask a question. There are two things which you need to believe when you are doing Lean Six Sigma. One is you can't improve if you cannot measure. And the second is you can measure everything. So you can't improve if you cannot measure. First of all, do you agree with this, both rules? Yes or no? Do you agree? So when we talk about data, so first of all, you can improve everything, and of course you can measure everything. That is what we believe. We can believe why? Because there are two types of data, continuous and attribute. So all the data in the world can definitely be expressed as attribute data. Any attribute you can create minimum two categories, presence or absence of that category. And then of course you can think of major subcategories also. So when we ask about data, when I talk to people about data, when I ask about data, generally people say, oh, we do not collect the data. Why should I collect the data? Like attendance data. No, what we are asking is that respond in the chat box. You can respond in the chat box here. And when I'm asking some questions, you can respond in the chat box. Right? So data, if people generally ask, people say we do not collect the data. But good colleges, they have all the attendance sheets, line charts, graphs in real-time basis displayed in the administrative departments. Okay. Sometimes people say we don't have too much of data, like mostly in the industries we may talk about, and then but we don't know what to do with the data. And the third is analysis is too complicated. I can't analyze so much of data. So in this case, to remove all these doubts, we have to know that there are two types of data, continuous and attribute. Last time I had talked about in detail, but just to revise, continuous data is something which can be represented on a number line. It has got a decimal place. It has got a unit as well, like 55.5 days procurement time. And sample size, good sample size is 30 to 50 samples. Attribute data, you have got like good, bad, gender, male, female, etc. So all these things are examples of attribute data. So here 200 to 1000 samples is good enough when you are conducting a survey. So continuous data, attribute data, right? Two types of data, and based on the data only, we can do the data analysis, right? So I had just shown you some of the data analysis. So it's a good idea to collect the data from your college. And once you collect the data, based on the data which you collect, you can always think of analyzing it, getting the root cause, and also identifying the improvement opportunities, improvement areas in your college. So usually you do DMAC project, define, measure, analyze, improve, control. I just talked about some of the tools like SciPoc, Project Charter. Project Charter is nothing but writing your problem statement and goal statement in the define phase. Then types of data we talked about, normal distribution we talked about, cause and effect also we talked about, Pareto, box plot, scatter plot. I also talked about the process mapping, also talked about the brainstorming. This is not relevant to colleges, so so I'll just skip that part. So good, I have talked, and also we saw some rules, the basic rules of analysis. If I'm doing the analysis in Minitab, you can always download this minitab.com from Minitab software from minitab.com, and you can do your analysis, whatever analysis. If you are collecting the data, it's a very, very good, very beneficial thing to apply the data analysis to the data which you are collecting by using tools like Minitab or any SPSS. You must be using some tools anyway. And then, in fact, there are advanced tools like regression and chi-square and ANOVA. Of course, I have not discussed here, but if you want, I can just talk about them. Here, like for example, when I'm talking about attribute and continuous, I told you we'll do a box plot. Continuous and attribute, we'll do a box plot. But instead of box plot, you can do ANOVA. So equivalent of box plot, the graphical technique we saw was box plot, it is ANOVA. Equivalent of scatter plot is regression. And equivalent of Pareto chart is chi-square test. So chi-square test is used when both are attribute data. And both are continuous data, then we use regression. And both are, one is attribute and one is continuous, we use ANOVA, analysis of variance. And in all the three cases, we look for the p-value. P-value is less than 0.05, that means that factor is significant. Say for example, scores. Is it impacted by, let's say, interest? Because it is continuous and attribute, I will use analysis of variance, ANOVA. Scores of the students and interest. So these are the two factors which I want to see whether they are correlated. If I get the p-value of less than 0.05, that means interest is significant. Interest is significantly impacting our scores. If p-value is more than 0.05, I will say interest is not significantly impacting my scores. Because I'll be happy to talk more about that theoretical background and from where I'm getting those p-values, but anyway, there's not much enough time for that. So now if I just look at this p-value, they are statistically different, isn't it? Looks like statistically different from the graph. P-value is less, it's 0. 0 means, yes, they are significantly connected. Interest is affecting the scores. But how about the branch? Okay, let us see. Scores versus the branch, ANOVA. Scores. So let us see the p-value now. So it is actually high, p-value is high, that means it is not connected, right? So this is how actually we do our analysis. So yeah, I think I've very much covered some of the quantitative based techniques, which you can use to improve your processes in general. And that is also one of the things which typically a yellow belt must know. So if you have any, okay, can you please tell us any other tool other than SPSS? So there are so many. SAS is there, SAS. There is Minitab is there. I was talking about Minitab. Yeah, Minitab is there. And these are all freely downloadable, so you can download the at least demo versions and you can use them for your analysis. If you want, I can talk about chi-square also, chi-square tests. Up to you. Or if you have any questions, just let me know. I can also talk about regression if you're interested, but it's up to you. So yeah, any questions? Do you have any questions? Anything you would like to ask on whatever we have covered? Are you aware of regression? Okay. So I think if, any questions you have or whatever we have covered till now? So can you think of some things which you can improve using those tools and techniques in your colleges? Okay. Okay, so let me talk about the regression also. So regression is when I am having both the x factors, both the factors are continuous in nature. So I can create a regression equation. Regression equation is in the form of a straight line. Y is equal to a plus bx. That's the equation of a straight line. So let's try to correlate scores and the industry interaction, scores and the uh, hours of industry interaction. Are they related? Or scores and the study hours. So are they related? So I can just do a regression, go to stat regression, and regression, fit regression model, scores and study hours. Let us see, are they related? So p-value is 0, that means they are related. Industries interaction. No, study hours. Study hours is important, is significantly impacting the scores. And the scores is equal to 2.25 plus 1.19254. This is like scores. How much will you can expect the score? If you study for 100 hours, 100 into 0.19 gives 19. Just use, you'll get only around 22 as a score. If you study for 200 hours, then it will be like around 50. You will score 50 and so on and so forth. So you can predict the scores as well. Now these are all, of course, depends on how much data you are able to collect. And we highly encourage a lot of research work in the engineering colleges. In some of the colleges, they have done this research work. Like I was talking about the colleges in Middle East, the engineering colleges, college in Dammam, very famous engineering college, King Fahd Petrochemical Institute. So they had collected, see, you don't have to collect too much of data, like 30, 40, 50 samples is good enough to make some conclusions. And they have published those papers also in the journals. And these are available, in fact, as a case study on the website as well. So you can search for those case studies, Lean Six Sigma applications in colleges or in education. Okay. Okay, good. So I think, yeah, I have covered virtually all the tools and techniques. Actually, I had put some around 20 minutes for interaction. So if you're, yeah, okay. So what are the factors to be considered in colleges for quality control? Yes. See, first of all, the measures, the factors which you want to determine for quality control. See, first, as I said, our focus general and the industry focus is not only on quality control, it is also on quality improvement. See, most of the time we are just focusing on quality control. Quality control means I'm controlling where I am. Well, that is important because I need to achieve what I'm supposed to achieve. Like attendance should be 85%. Now, am I getting attendance at 85%? Really? If not, why not? And then I try to do an improvement projects on that particular measure. That's the attendance. How many publications or how many papers faculties are writing, and not only that, what is the quality of those papers? How many faculties are able to interact with the industries? How many faculties have visited? How much time faculties have visited in the industry? How many times they are associated with the industry? Are they do they spend time in the factories? If you are teaching, say, mechanics, or you are a professor of mechanical engineering, during the whole year, how much time, how many days you have spent in the industries, related industries? So not only spent, but also being part of the productive team. It should not be just like a formality. It should be how much time you have spent as a productive team. Then another thing, one thing I can suggest, lot of people in the industry, they are willing to come to conduct some lectures in the colleges. A lot of people, they are willing to invite them. And once you invite them, people from the industry, the faculties will also learn from them. That is one thing. So some of the students, like, not only will get industry interaction, but also the faculties will also learn what is happening new in the industry. So not only theoretical. So that is some things. Now, so some of the factors, now to just to answer your question, what are the factors to be considered in colleges for quality control? Some of look at what, are you affiliated to any university? What are the factors, the KPIs university has given? Okay. So does I'm sure university has given some KPIs or the factors, some of the factors which you have to, yeah. Now, which are the factors? I'm just taking, you don't have to tell me, but you have to identify which are those factors. So these are the primary factors for your quality control. Consider them and then place those numbers, place those measures in the respective departments, in the respective areas, so that we know how are we performing in those terms. Can you give me any one measure, any one factor which is important, which K2 has told you to can you give me one factor, any one factor? Pass percentage of students. Okay, I think, yeah, I just talked about that. Passing percentage of student. So I gave you the whole process of, how to increase the passing percentage of students. So these are the factors. So for the factors, mostly, these are the placement percentage, right? So placement percentage, passing percentage, measure these, display it somewhere very prominently in the corridors of the colleges. People will, that really impacts a lot. We call it as visual control. It should not be hidden in some files or some papers. It should be displayed in prominent areas. So that is one thing which, will really help. Okay. How to measure the quality of education in engineering colleges? Okay. So quality of education in engineering colleges, the best thing would be, when we, I'll just tell you, after every class, there are nowadays, every student has got mobile. There are applications where you can download these applications and you can conduct an online survey immediately, within seconds. So create a survey. After every class, the faculty should know what was the feedback of the students from the class. So after finishing every class, this survey can be done on those applications, and this will help the faculty to understand overall, how's it going. Sometimes one lecture can be not well understood by the students. Sometimes it may be easily understood. Sometimes they enjoy, sometimes they don't enjoy. So once you gauge your performance on a real-time basis, that will definitely impact it. Now, it can be initiated with the by the faculty. Means only the faculty is aware of those scores, maybe, because if you put it as a performance scores, etc. And then there are a lot of things, start coming into picture where, it becomes more of a defensive mechanism rather than, improvement mechanism. So if you really want to make use of this particular uh, system, ask the faculty to create their own surveys, and only the faculties will get the information about it. No one knows about it. Only the faculty know, okay, today, satisfaction scores were 80, today it was 60, today it was 90. And that also will motivate the faculty to make changes to the way, you're giving the lecture. So that is one thing I can think of for quality, to increase the how to measure the quality of education in the engineering college. That is one thing. One more thing can be conduct. The same applications can be used to do quick tests. Quick tests like a polling. You generally do a polling, right? I don't like even in this Zoom also, you can do very easily the polling. So while the student is lecturing, so for the faculty is lecturing, you can ask the students to get immediate feedback, immediate reaction. Like, okay, ask a question. How many of you think something, something, something? And then give them the option, 3 options. They can choose that option. And immediately it can be displayed on the graph. Okay. So that is one thing which, will increase the quality of the education in the engineering colleges. How to improve the quality in education during these COVID-19 situations? The COVID-19 situation, most of the time, focus on the online. Focus on the online, use the, so much of material is available online nowadays related to all your subjects. Pull out that material, use that as a study, as a presentation material during your lectures. Nowadays, most of the lectures of the very famous professors from best of the best colleges for each and every subjects are available. Use them during your lectures. Okay. Get them, or at least you learn from those lectures, and then while you are presenting, it will also improve your quality of presentation. So that is, I am sure, just you can get access of almost all the lectures of almost all the subjects, all the chapters from one of the best colleges. I know some of the colleges, engineering colleges, they have put everything on Berkeley University of US. It puts all its lectures on the web. You can access them. Of course, you have to go to their internet site, and then you can get access to everything. Have we seen that? As a faculty, definitely. You can. This will really drastically improve. Because maybe the students maybe find it very difficult because they are busy watching not definitely some other interesting stuff, but faculties definitely can access those lectures, and then they can use those techniques. And some of the times you can even play during your lectures. You can play those videos that really will enhance our lectures and, of course, the quality of the education. One more thing, like one thing comes to my mind. When you are talking about education, when you have got access to all the education, like talking about in terms of pandemic I'm just referring to that as well. After some time, see, when every student had got access to all the best of the best learning materials on the web. Only thing is the person's motivation to access that. See, availability is there. So the role of the faculty would change from a teacher to that of a facilitator. That's what going to that of a guide. As a guide, like these are the videos you should see. These are the things which you should learn. These are the. It will be more like a facilitator, more like a guide, more like an advisor. The person in physical, uh, you know, presence, it's also important. So everything can't be outsourced. Everything can't be going online. But the role of a faculty, as a faculty, if you are more like a facilitator, advisor, referring to so many videos, so many of lectures, all the IIT lectures. In fact, NPTEL, and I think NPTEL has done all the lectures, all the engineering lectures are available free of costs by IIT professors. Have all the faculties seen those lectures? These lectures are available. But still, if we are not watching and learning from them, then of course, it's like you have to do that. That's something which is very, I would say, important. Okay. So that is one thing I wanted to talk. Yeah. Will NEP will bring about a change in engineering colleges? Now that I can't comment much about. I don't know much about NEP, so I will not be in a position to talk about that. Yeah. Any other questions you have? But there will be a lot of change in the education system. 100%, I can tell you that. One thing is for sure, and I hope you agree. All the best of the best material is available. Best of the best lecturers are lectures of all the subjects are available. A lot of knowledge is available. All papers, published paper, everything is available. Now it's up to you. It's up to you how much you can access. Now, uh, if you're not taking advantage of this, then definitely we'll be left behind. Okay.
Thank you, sir, for your valuable suggestions.
Yeah, thanks a lot.
I would like to thank our eminent speaker, Mr. Amitabh Saxena, for making excellent presentations and making this session interesting and meaningful. So you gave a real focus on the Lean and Six Sigma implementation into the current educational scenario. On behalf of all the participants, I would like to express our appreciation for your willingness to present again a session for the second phase of the STTP. Thank you very much, sir. Now we come to the end of today's session. Attendance and feedback link of the session will be shared now. Once again, thank you all. Sorry.
Okay, thanks a lot. Thanks a lot to everyone.
Thank you, sir.